Good afternoon, and thank you all for joining us for our webinar today as we talk about exclusive tips and tricks for CAMWorks. Today, we are joined by Lindsay Morrison, Director of Digital Manufacturing at CAD Micro. Before I hand things over to Lindsay to kick us off, there are a couple of quick housekeeping items to mention. First, as usual, we'll save a few minutes at the end of today's session for a question and answer period. Feel free to type your questions into the Q&A pop-up as they come, and we'll do our best to get them at the end of today's webinar. The webinar will be recorded and we'll be sending you the recording via email tomorrow. If any questions do arise afterwards, you can feel free to reach out to us and we'll be in touch shortly. All right, without further ado, I will pass things over to Lindsay to get us started.
Perfect. Thank you, Shreya. I'm just talking today about some CAMWorks tips and tricks. So I'll switch over to the agenda here. So these are just some different items that we quite often get asked about on a daily basis. So I just wanted to cover some different tips and tricks within the CAMWorks software. So the first one we'll talk about are useful display options, so different display options that are available inside of CAMWorks and different display options that we can change and edit. Quick and easy toolpath strategy selections and changes. So when you're programming inside of CAMWorks, when a strategy is selected by default, we can easily change that without having to go through the right-click menu each time. We're also going to talk about 3-axis radius cutting methods, so different tool pathing options to cut radiuses using 3-axis toolpaths. Multi-axis linking overview, so how to link between cuts and during cuts. And then 4th and 5th axis machine setups. So how that works and how easy it is to set up an actual 4th and 5th axis machine. So with display options, this is again going to be under your CAMWorks options window. So inside of the command manager, you can use the arrow on the right-hand side of the command manager and locate your CAMWorks options. The display tab is essentially what we're going to be talking about within this first tip and trick discussion. So inside the display options, and let me just quickly pop over into the software so I can show you that window. If we go into CAMWorks options here, you can see that there is the display tab. Just to also let you know, you can also find that window by going to Tools, CAMWorks, and Options, and then Display. Now, I do want to point out all of the display options that we're changing here are specifically for machining. If you are looking for any kind of display options for the part itself, that would be under the CAMWorks options. So you would select the options window at the top of your screen for SolidWorks, and that would be under the SolidWorks options. So anything to do with the machining, kind of colors or lines or labels, that kind of thing, that would be under CAMWorks options, and then anything else to do with the part itself would be under the SolidWorks options. So under the display window, the very first thing at the top here, you can see as you click through each of these, again, if you're looking to kind of change the color of any of these items, you would just choose the edit here and choose a different color. There is the option to define custom colors in here. So that's something that people often look for, is changing the colors. Some of the items are very similar in color. So the highlight versus the tool are very similar blues. So if you want to change those can easily be changed. You can also reset them at any time back to the original defaults. I'm just going to pop back into the PowerPoint here to talk about the use feed-based colors. So when we click on the checkbox for use feed-based colors, this feed color setting option under edit feed colors will show up. And this is actually where we can type in a min and a max feed rate and apply a different color for those. So again, this is not turned on by default. So this is something that can be added as you're working. The display stock outline, basically when this is checked off, the stock outline, as you can kind of see on the right here, will be turned on at all times. So quite often this is something that people would like to see all the time. So we can turn that on. And if it is not turned on, you would just need to hover over the stock manager here. And as soon as you hover over the stock manager, it will show the stock highlighted. The display fourth and fifth axis C and B labels, again, this does not need to be turned on if you are using a 3-axis machine, but if you are using the fourth and fifth axis, I highly recommend because this will go into the label section and it will add in, as you can see for this one would be the fourth axis, a rotary of 180 degrees where it's actually showing. So these are super helpful when you are programming. I highly recommend turning them on if you are using a fourth or fifth axis machine. The next one I want to talk about is the 3D origin marker. This should be turned on by default, but if it is not, please make sure that you check this off. This is again going to show your CAM origin point. If this isn't turned on, all you would see is the SolidWorks origin. So we definitely want to make sure that we see the CAMWorks origin and where that Z-axis is pointing. So that's the display 3D origin marker, and we want to make sure we turn that one on. There is an option here, this display tooltip for operation parameter. I'm just going to quickly show you that one. So this is display tooltip for operation parameter. What that is if we click on a toolpath, you can actually see all of the tooltips that show up on the right-hand side. So these are all of the different settings inside the actual toolpath. If we right-click on the toolpath and choose Edit Definition, all of the different settings that we set up inside of the toolpath can be seen in this tooltip. So that's a really good option for sure as well. So that's display tooltip. The next one here is split tree view for active dialog. So basically, as soon as you open any kind of window, you can see that there's two separate tree views. So I'm going to show that in the software as well, just because it's a little bit easier to explain. If we right click and choose edit definition on the toolpath, you can see that there are two tree views that are available on the left-hand side. So this actually allows us to see both, say, for example, the CAMWorks feature tree as well as the operation tree at the same time while we have any window open. So it's another nice option within the display window. The collapse operation dialog on preview, basically anytime you are making any changes to anything, again, inside of the operation parameters. So again, if we open up the operation parameters, if we press the preview button here, you can see that it minimizes the operation parameters here at the top. So basically, any toolpath that you're changing, it's just going to minimize that. You can just open that back up. If we go into the next one here, and we make some changes to a screen, we press preview, again, it's going to minimize. You'll also notice that this is, so say for example, if we're closing the toolpath on the roughing tab, so I'll press OK here, and then I open up another roughing toolpath, it is also going to open up on the roughing tab. And that's actually the next setting that we have in here. So if we switch over here, it says open all operation dialogues to the last page. So basically whatever tab that you had open will open up to the next, that same tab in the next window. So just to kind of highlight some of the different options in here, these also will be completely explained inside the help menu. So please take advantage of the help menu if you forget what some of these checkboxes do. But again, this is a really helpful tab to cover the display settings. You'll also notice that there is the origin size factor and the toolpath start marker size factor. So again, the origin is the CAM origin, and then the toolpath start marker is this X here. So again, the size factors can be changed in here if you want them larger or smaller. And same with the line weight. So again, this is specifically for your toolpaths or the highlighted machinable features. So the line weight can also be changed. These options you can definitely play around with, but the defaults are fairly good to kind of start with. But again, you can always make those larger or smaller as you're going. The next thing that I wanted to talk about was strategy selection. So quite often people are selecting their strategies manually. So let's say, for example, if we're going into to select a strategy, so say, for example, on this brown pocket, we would right click and we would go to parameters and we would change our strategy here. So let's say it's just a rough mill is all we want. We would press OK, and there's the strategy that's been changed. Another quick way to do that, if let's say, for example, you wanted to change a whole bunch of strategies at the same time, would be to use the default feature strategies inside your command manager. So again, under the CAMWorks tab in the command manager, or you can access this through tools, CAMWorks, and should be in here as default feature strategies right here. So when we open this window up, what this allows you to do is you can actually see in brackets beside each of the strategies that, or sorry, the features that have been found on this part. So the countersunk hole was used 11 times. So again, if you don't want to go through each of these features and change the strategy each time, what you can do is I could say, for example, the irregular wrapped slot feature. I want to change these all to just rough finish. I can go ahead and press apply, and now you can see both of the irregular slot features have been changed to rough finish. And same with the one on the second setup as well. So this is just a really quick and easy way to change your strategies. Another option with the default feature strategies is to set up different strategy selections based on the machine. And that's actually set up in the technology database. So I'm going to quickly show you that as well. So when we open up our database, if we look inside the main page, so this is just under the mill tab, any different machine, they would all have the same settings, but you can see default feature strategies is listed here. So this is going to show your default settings. So again, this is all of the default feature strategies that have been selected. You can change this. This is the default for every single machine that I have listed. But you can also set up a different set of strategies for different machines. So let's say, for example, I wanted to set a different strategy for maybe a laser machine. So I could copy the default. I can call this maybe mill 3-axis. And then I can go through and I can change whatever I need to change within this setting. So I would go through and set up the default feature strategies. Again, if this is maybe a laser machine or a router, maybe you just want to finish strategy. So you can adjust that. We would save it until we see mill 3-axis. And then you can see that it's not assigned to any machines. The default is still assigned to all of the machines. So in order to use this setting, this default feature strategy setting for a machine, we would come back into our milling machines, find the machine that we want to assign that to, and then you can actually see here default feature strategies in the general tab. We can change that now to mill 3-axis, save, and now we can use that for that specific machine. So if I come back into default feature strategies, we click on mill 3-axis, we can now see that that mill-inch machine is now assigned to that set of strategies. So this is a really quick and easy way to adjust the default feature strategies that are selected for that machine. So I really like that feature. The next thing that I wanted to talk about was 3-axis radius cutting method. So this is the ability to cut a radius on a part using different tool paths. Quite often in 2-axis, what we're using to cut a radius would be a corner round tool. So we would take that tool and we would just wrap it around the actual radius. In some cases, people want to use a ball nose tool to cut the radius. So what I would recommend would be using a 3-axis tool path with a ball nose tool. So if we come into the CAMWorks feature tree, we would add in a multi-surface feature. So again, I would right click on the setup that I want to add it to and add in my multi-surface feature, and I'll just open up the one that I've already created. And I set this one to all displayed. So it's basically taking into account all of the features on this multi-surface feature on the part. I selected just area clearance pattern project as the strategy. It doesn't really matter which one you create, because you can right click on it and then add in whichever tool path that you want to add. So if we look here, the first one that I added in, I'll show you quickly the simulation of the part before we add in any of the features, just to show you that the radius is the only thing that's left to be cut. So if I use my display option and my show difference, you can see that top radius is the only thing left to be cut. So that's what we're going to use the ball nose for. So I'm going to unsuppress the pattern project toolpath just to show you this is one of the options. So pattern project is a 3-axis finishing toolpath. And what we can do is, you can see the ball nose is the tool that's been used to create this toolpath. And then under the pattern tab, I've actually used the flow line pattern. So I created a curve 1 and curve 2, curve 1 being the top edge of the part, or of the fillet, and then curve 2 is the bottom edge of the fillet. So what I can do with that is kind of keep the tool in between the two edges, and then it just goes around and cuts that fillet for me. You can actually see it's come down onto the floor here, so I could actually adjust where that's cutting with curve 2. So this one's actually offset 0.1, so I could say 0.05 or something like that, to limit it to where that toolpath is being created. So that's the pattern project toolpath. It is now just staying on that fillet. So that's one option. Another option, so I'll just suppress that one and bring up the Z level. So the Z level is another option in here that allows us to create the toolpath on the fillet. So this again is just using a ball nose tool. I've set this as a Z level cut type. You can see I've set the scallop in here, but I also turned on the hit flats option, because that's how you're going to get it as close as possible to the top edge. If we don't have hit flats, it's going to try and cut the walls of the fillet instead of getting up closer to the top edge, so it wouldn't give us a nice smooth finish onto that top surface. So if you are trying to use the Z level tool path to cut the fillet, I highly recommend using the hit flats option. And you'll also see that I limited the tool path. So when you add in a Z level tool path, it's going to try and cut all of the steep areas. So it would try and cut these walls as well if we have all displayed selected. In this case, I used from top of stock to a user defined value. So you can actually see where that's located. I had it set to this point here. I just selected this point, this vertex, and then I did a negative offset to move it down a little bit so that it again gives us a nice finish at the bottom of the fillet. So depending on where you want that to be set. And contact areas only, so that it's only cutting where there's material to cut. So that's another really good option. And I'll suppress that one. And then the last one that I'm going to talk about with 3-axis, if I unsuppress this, would be the constant step over. So this one's quite often used as a finishing tool path. And what the constant step over does is, again, it just creates a constant step over on the surfaces that you select. And in this case, I created a containment area. So the top edge of the radius, or sorry, of the fillet. I created that as the containment area, and I actually had it offset a little bit, so comes outside of the actual fillet by 0.03. And then I also had an avoidance area on the inside. So again, containing it between those two areas. And then if we go into the constant step over tab, you can see that the offset curve is between the contain and avoid area, not just contain only, both contain and avoid. And then there's my cut amount. So that's another nice tool path that just loops around and gives us that nice fillet shape. The very last option that we do have would be the multi-axis mill option. So the multi-axis mill option, I've created a second multi-surface feature. And this multi-surface feature, you actually need to select the faces for. So faces or surfaces need to be selected to create a multi-axis toolpath. And inside the multi-axis toolpath, we want to limit this to 3 axis. So if I go into my axis control tab here, we want to limit that toolpath to 3 axis. So it's not 4 or 5 axis, just 3 axis. Obviously the tool again is the ball nose. And then if we go into the pattern, there's quite a few different patterns that can actually be used for this toolpath. So in this case, I've done offset from curve. I selected one of the edges as the curve and then have it offset from there. So you can see start and end at exact surface edges. And then I have close first and close last cut. So it does a nice surface finish at the top and at the bottom of this fillet. It's also using a spiral pattern to continuously loop around. You'll notice in most of the other 3-axis toolpaths that I had, there was a linking motion between each of the steps. So this spiral motion will give us the smoothest possible option. This is one of the reasons why I really like this toolpath. There's obviously a lot of settings inside the multi-axis toolpath, but this actually allows us to give us the best possible situation for the radius. So that was the offset from curve. There's also flow line between curves that could be used, flow line between surfaces. There's quite a few different options that could be used within the multi-axis toolpath. So that's what I used for that one, and I used the max step over as 0.03 to give me the nicest surface finish there. So again, if we kind of simulate through this and take a look at the finished result, we should see a nice radius around the outside. Like that. So like I said, there's quite a few different options for adding that radius in. Again, the pattern project, Z level, and constant step over are really great options that I've found. There are other toolpaths that probably could, or different settings within the toolpath that could do this as well, but those were some really easy options for me. And again, make sure if you have created something like this that you really like for a radius, you can right click on that feature and save the operation plan. So save this back to your database, create a strategy specifically for fillets, and then you can use those settings in the future. The next thing that we wanted to talk about was multi-axis linking. So this is another multi-axis option that I'd like to show inside of CAMWorks. So we do have the multi-axis toolpath open here. So let's just pop right back in there. And the linking motion is basically the link moves between each of the steps. So let's go back into the pattern tab. I was talking about the spiral earlier. If we change this to a zig motion or a zigzag and we press preview, you should see the links. So that's the links between each cut. So each level is a different cut, and so there's a link move between each. There's also the option of links along cut. So in the PowerPoint here, you can actually see in this image, this would be a link along cut. It's still making the same cut move, but there's a gap in the center here. And so that would be the link in between. These would be the links between the cuts. So there's quite a few different options that allow us to adjust what we're actually setting for those links. So links along cut and links between cuts, and that's how it's kind of separated within the multi-axis toolpath. Links along cut, you can see that there is a link threshold, and this is actually a percentage of the tool diameter. You can see the percentage button here. If I turn that off, you can actually set an exact value or size. If I turn that back on, again, it's taking the information from the tool. I just want to point out also with this toolpath, we go into the help menu. It opens up directly to the links tab, and we can click on links along cut here, and it shows the exact same information. I highly recommend taking a look at the help menu. especially if you're working with a multi-axis toolpath, because it's super helpful. And there's quite a few images that will help you along with this. So you can see link threshold sets the threshold for gaps along a toolpath as a percentage of the tool diameter. So that's the link threshold for the links along cut. And where that comes into play is you can see the gaps are less than or equal to the link threshold. This is what I want it to do. And if the gaps are greater than the link thresholds, this is what I want it to do. So once we've figured out what size that actually is or what those gaps are, then we can choose a different link type. So do we want it to give us a direct link from one side to the next, or do we want to retract to a clearance height? Whatever you want to set that to. So again, you can make that different based on the threshold value, which is super helpful. The next option in here would be the links between cuts. And that's actually what this is set to here. So again, these would be between cuts. They're all different levels. Now the link threshold is a little bit different here. And again, if I open up that help menu and I go to links between cuts, we can see that the link threshold is actually an absolute or a percent of the user-defined max step over. So the max step over is actually found if we come back into the pattern tab right here. So this is what it's actually based on. So if I come back into the links, 120% of the max step over. If I turn off the percentage, you can see that that's the actual value. So we can set that to whatever we want that to be. And again, that's going to be links between cuts. And then we choose the step over is less than or equal to the link threshold, or the step over is greater than the link threshold. So whatever we want that to be, let's say, for example, if we want this to be retracted clearance, we press preview. Oops, and sorry, this is going to be retracted clearance, and press preview. You can actually see that the value is greater, the step over is greater than the link threshold value. And so then it's retracting to the clearance height, whatever we have set as the clearance. So retract to the feed distance, we can press preview, and you can see now it's just retracting to the feed. So this is essentially how we look at the links between cuts and the links along cuts in a multi-axis toolpath. Again, you can use this in 3-axis as well. Under the axis control, we can limit this to 3-axis, 4 or 5-axis for our multi-axis toolpaths. So that's the links. And again, I highly recommend using that help menu if you do have any questions about any of these items, because it's super helpful and we can see all of the images and it kind of shows us exactly what each of those options does. You can see exactly what the direct does, retract to feed distance, and so on. The pictures obviously in here are also super helpful. And you can also use lead-ins and lead-outs for each of these. So if I do want to set a lead-in and lead-out, I'm not going back to the entry retract tab. It's actually a setting right here. There's a little button that shows up to the left. I can open that up, and then I can set a lead-in and lead-out specifically for the links. Okay. And the next thing that I wanted to talk about was the 4th and 5th axis machine setups. So quite often people will look at 4th and 5th axis and think that it's going to be extremely complicated to set up the machine inside of a CAM software, but CAMWorks makes this extremely easy and straightforward. So I'm just going to open up the part here. And the first thing that I'm going to do is actually create a new, this one has a whole bunch of toolpaths on it already, but I'm just going to quickly create a new configuration as if we're starting from scratch. And just to show you, there's the older configuration and this is the new configuration. This is another option that you can use if, say, for example, you wanted to have multiple programs in one part or one assembly file, and another option if you wanted to maybe use different machines, that kind of thing. So the first thing that I want to talk about, especially when using 4th and 5th axis, even 3-axis, honestly, I would highly recommend creating your coordinate system inside the part file or assembly file. So inside your design tree in SolidWorks. So you can see I've created this fixture coordinate system. It's kind of hard to see there, right there in the center. And this was actually created as a SolidWorks feature. So if I come back to the assembly tab, I'm in an assembly file, but this can be done in part mode as well. And if we go into reference geometry, we've got coordinate system here. So that's how I created this fixture coordinate system. I placed it in the rotational center. So again, you're just kind of clicking in the center of any of the circular features here. So whatever it's rotating about. And then we want that Z axis to be pointing up in the direction that our tools are coming in. So in that vertical direction, on this machine specifically. So again, depending on your machine setup, where is the rotation? This one's currently about the X. So that's what we've set this up as. And again, I can change the Z axis. It just needs to be a flat surface, and we know the table should be flat. So that's the fixture coordinate system, and that's inside of SolidWorks. I also renamed it to fixture coordinate system so it's easy for me to pick up when I'm adding this into my program. If I come back into the CAMWorks feature tree here, the next thing that I want to do is set up my machine. So under the CAMWorks 2023 tab in the command manager, you can see that we've got define machine. If I click on define machine here, these are my milling machines. I want to set up my 4th axis machine. So I'm going to go ahead and select that 4th axis machine. If I come into my tool crib, obviously I select the tool crib that's associated with it. And then I'm going to select the post that matches that. Under the setup tab is essentially where we turn this into a 4th axis machine. So you can see under indexing, we have none. This would be a 3-axis machine, 4 or 5 axis. If we choose 4 axis, it automatically turns on the indexing. So the rotary axis options become available, and the tilt is turned off because that would be 5th axis. If I'm setting up 5 axis, then I have both rotary and tilt. So that's the 2 options there. With 4th axis, you can see that I've got a min and max rotary axis that I'm setting up. So you can see I've got a negative 360 degrees and a positive 360 degrees. It depends all on the limits of your machine, but you would enter your limits specifically in here. And then the next important thing that we want to set up is the fixture coordinate system. So this is essentially where we're saying we want to use the coordinate system we just created in SolidWorks. So I'm going to click on define. And instead of using the user-defined option inside of CAMWorks, we are going to use the SolidWorks coordinate system. Now, again, you can set up user-defined in CAMWorks, but if you are going to change anything in your CAMWorks program or create a new configuration or anything like that, it's best to have your fixture coordinate system inside your SolidWorks part or assembly, because you can always access that exact same coordinate system. You're never going to lose that information. So SolidWorks coordinate system is the method, and then I would just click on that coordinate system. And again, if I'm not sure if I've got a bunch of different coordinate systems inside my part, you can take a look at the tree and see which one is the one that you need to use. So available coordinate systems is just the one that I've got here. We'll go ahead and choose OK. And then you can see my fixture coordinate system now says edit instead of define, and that's been set up. And you can see also beside coordinate system here, it says FCS in brackets. So I know that I've set that up correctly. The next thing that we can take a look at is under the rotary axis tab. So again, I've turned on my rotary axis. So now the rotary axis tab has information in here that I can fill out versus it being grayed out previously. If I had none turned on, then rotary and tilt are both grayed out. If I switch this to 5 axis, then I have both rotary and tilt. And again, if I switch this to 4 axis, then it's just rotary and the tilt is grayed out. So again, kind of opening up whatever you're setting this as. Just want to make sure the coordinate system's still there. And then I have my rotary axis set as the X axis. If I want to reverse that direction, you can see now the arrow is pointing in the positive direction. I can adjust that. And you also have the option of a rotation direction. So does yours rotate in counterclockwise, clockwise, counterclockwise, or both? In my case, it's going both directions. And then the last thing that we want to set up is the 0-degree position. So the 0-degree position is essentially where is that 0 position in my rotation. So in this case, I'm setting this as my XY plane, but you can also adjust that. You'll also see that there's an entity select in both of these, so you can adjust these and change them to whatever you need to and select items on the screen. So that's the rotary axis, and then we would press OK. And that's our coordinate system, and our 4th axis machine is all set up, and you can kind of see a little preview of that in there. So I'm just actually going to go back into my previous configuration with all of the tool paths. And if we take a look at something with toolpath that's set up with the 4th axis, again, these are the labels that I have turned on in my display for the 4th axis. So if I look at setup 2, it's rotated at 180 degrees. If I right click on it and choose edit definition on setup 2, and I go into my indexing tab, you can see that this is the rotation. So it's choosing a positive 180 degrees. We can also adjust that if we wanted this to do it a negative 180 degrees. You can just press select here, and it's going to use that direction instead. So you can switch back and forth, whatever you need that to do. If it's closer to going one direction versus the other, you can adjust that. So that's the 4th axis setup. When we post-process with the 4th axis, so again, you have to have obviously the post selected, the correct post to output 4th axis toolpaths, but if we post-process, just save that and choose OK and open this up into my CAMWorks editor, we can actually see, so this is my A, and then you can see that that's changed to 180 degrees on that second roughing toolpath. So we switch back into the toolpath. So rough mill 12 here on the first setup was at 0 degrees, but then once we get to rough mill 6, it's going to switch to 180 degrees, and that's what we've got here as the A value for that rough mill. And so you can kind of scroll through and obviously make sure that all of the A values are called out in the correct direction. But that's essentially how we would set up the 4th axis. So 5th axis would be the same. Obviously, we would just add in the tilting. But the biggest thing to note is it's really just turning on those options inside of the machine settings. So the setup tab, choosing the indexing as 4th or 5th, and then obviously setting your rotary and tilt axes. The post processor does a lot of the work with that. So obviously if you need a post processor for 4th or 5th axis machine, please let us know and we can source that for you. But that's essentially how we would set up the 4th and 5th axis. So that's really all I had to cover today, just a few different options that we get a lot of questions about. And I think that that's pretty much it.
Thank you, Lindsay. That
Yeah.
was a great presentation. We do have a few minutes left for questions, so keep them coming. We got a couple in the queue already, so let's go ahead and get started. The first one we have here is, how do you save 4th axis machine settings so that you can use them in the future?
That's a good question. Okay, so let me just open up the software again. Basically what I did previously, so if I have defined machine, I've kind of just manually selected these, but all of this can be found inside the technology database under the machine. So let's say, for example, if we go under the 4th axis machine here, we can see if we kind of minimize some of these tabs here, under the setup tab, so again, that's the setup tab inside the machine settings, you can see indexing is now turned on to 4th axis. You've got the rotary axis min and max is in here as the default. We've also got the rotary axis set as the x-axis. So again, all of this can be set by default just within your machine settings. So that's kind of why I didn't really need to change a whole lot when I went in to edit that. But inside of the technology database under your machine settings, and it's the setup tab, and that's where you would set all of those up.
Awesome, thank you.
Mhm.
The next one we have is, can you use a ball nose tool to cut a radius in SolidWorks CAM?
In SolidWorks CAM, yeah. So if I'm just going to switch back to this previous part here. So this Z-level toolpath that I had set up, this Z-level toolpath is actually included in SolidWorks CAM. So yes, absolutely, you can actually use this in SolidWorks CAM. It would be the Z-level. All of the other toolpaths, so pattern project, constant step over, and multi-axis, you would actually need with CAMWorks, but the Z-level option you could definitely do in SolidWorks CAM.
Okay, thank you.
Mhm.
We have one more here. Which CAMWorks module do you need to have to use 3-axis toolpaths?
Perfect kind of addition to that one. So if we go into the PDF here, just showing the different modules. So you can actually see, so here's the SolidWorks CAM Standard and Professional, and then we get into the CAMWorks. Each of these has an option for 3-axis. So with the 2.5-axis milling plus, you can see, so this again is your where are we here? Z-level finishing. So there's the Z-level toolpath that's included in SolidWorks CAM Standard and Professional. If we go up into, so you can see here, 3-axis milling level 1, please obviously reach out to us and let us know if you want this document. But this kind of explains most of the 3-axis levels. 3-axis milling level 1 would give you different options inside the Z-level finishing. So you can add in a combined cycle for steep or shallow machining. So that's another option that's added in, and that's specifically for SolidWorks CAM Pro, and then getting into all of the different CAMWorks modules. And then level 2 and level 3 add in, so level 2 would add in all of the different finishing tool paths that CAMWorks offers for 3-axis. And level 3 would add in that multi-axis operation toolpath. So I'll open that one back up. So that's this toolpath that I was kind of talking about at the end. This toolpath is really great because there's so many different options that can be adjusted in there, and you can make basically the toolpath do anything that you really need it to do. So this one is the most flexible, I would say, and that's kind of why it's level 3, but all of the rest of the toolpaths, so let's say all of these toolpaths in here would be included in level 2. So we'll open that back up. So level 2 is included in all of these packages. So CAMWorks Milling Standard, Milling Professional, and CAMWorks Premium. And then the milling level 3 would be Milling Professional and CAMWorks Premium.
All right, that's about all we have time for today. Once again, thank you so much for a great presentation, and thank you all for joining us here this afternoon. We hope to see you again soon. Thank you.